back to my YouTube channel. In the course of this video lesson, I'll be explaining on how to name compounds that are alkanes, specifically organic compounds. Now, I believe you can see different practice questions on the board. And how do you identify a compound that is an alkane? Definitely, you will see that that compound have single bonds between the carbon-carbon connection and also the carbon-hydrogen connection, and as well as the carbon and other substituent connection. There will be what? Single bonds. So I believe this must be noted. So moving further, let's start with the first practice question. And there are rules on how to name organic compounds. And the first of them here is identifying the longest continuous carbon chain, in the sense that you have to look at that compound and try to look at the carbon-carbon connection that was longest. So that becomes the longest continuous carbon chain. So let's start with the first example. Now, if you check this compound carefully, I can only see this carbon-carbon connection. So definitely, this becomes the longest continuous carbon chain. I believe you are following. So after we've successfully identified the longest continuous carbon chain, we have to number this longest continuous carbon chain, and you will number in the forward direction and also in the backward direction, meaning you number forward and also number backward. So this is what I mean. So you number this longest continuous carbon chain. So this becomes carbon 1. I'm numbering forward now. Carbon 2 and carbon 3, whereby let us number backward. So it's going to be number 1 as well, number 2, and also number 3. Now, please note this. You can see I numbered forward and also I numbered backward. There is a reason to why I did this. But in this particular question, I will not be explaining the reason, because this particular compound does not have a substituent. I'm going to explain in other practice examples, so pay attention. So looking at this compound, okay, this compound has how many carbons? We can actually see with our eyes that this compound has 3 carbons, and a 3-carbon organic compound is or should be called prop. Do you understand? A 3-carbon organic compound should be called prop. And since the group of compounds we are naming in the course of this video lesson, they are called alkane, so we'll pick the last name here. So this compound we are looking at becomes propane. Do you understand? So that's the name of this compound. Now, please note this. A 1-carbon organic compound should be called met. A 2-carbon organic compound should be called eth. Do you understand? A 3-carbon organic compound, as seen here, should be called prop. A 4-carbon organic compound, okay, should be called bute. A 5-carbon organic compound should be called pent. A 6-carbon organic compound should be called eggs. A 7-carbon organic compound should be called hept. An 8-carbon organic compound rather should be called oct. And a 9-carbon organic compound should be called non. And lastly, a 10-carbon organic compound should be called dec. So this alone will help us to name other compounds we'll be solving in the course of this video lesson. If you are just joining this community and you are seeing my video for the first time, do well to click the subscribe button to this channel so you don't miss out any other videos to be uploaded very soon. And also you can check out my other video lessons in the calculative aspect of chemistry, organics you are watching now, different aspect, metals, non-metals. Okay, do well to check these lessons. They will help you improve greatly in your studies. And also do well to give this video a like and also share these videos with your friends. So let's get into this other practice question. So what was the first step? I said identify the longest continuous carbon chain. So you look at the compound, look at the part of the compound that has carbon-carbon connected together, and you look for things. I can see them already. You can see it as well. So this should be the longest continuous carbon chain. Do you see? And also, what was the next step? Number this longest continuous carbon chain. You number forward and also number backward. So let's number forward. So first here become a carbon 1, carbon 2, carbon 3, carbon 4, and also carbon 5. Let us number backward. Carbon 1, carbon 2, carbon 3, carbon 4, and also carbon 5. Now, the reason I'm numbering in the forward and also backward direction, let me explain now. Because I said that in the other practice question, that's where I'll be explaining why I'm doing this. Okay, it's actually very easy. Now, the reason for numbering in the forward and also backward direction is to make sure that the substituent. Now, if you observe carefully, hydrogen and carbon, they are not really substituent. They are the major elements that makes a compound organic in nature. Do you understand? Because all these guys, they are regarded to be called hydrocarbons. So we have two elements here, which is what? Hydrogen and also carbon. So I believe you can say hydrogen in different positions. So I cannot call hydrogen a substituent. It is one of the major. Do you understand? Substituent is what makes up something. Do you understand? So it's one of the major elements that makes up organic compounds. So they cannot be called substituent, hydrogen and carbon. But meanwhile, any other thing that will appear should be called a substituent. So I saw a substituent here and it was Br. What element is Br? Bromine. Do you understand? So I had to number forward and also number backward. Now the reason is this. The reason I'm numbering forward and also numbering backward is because I want to make sure that this substituent I am seeing in this compound have a very low number as possible. So the number that should be ascribed to this substituent should be low. So if you observe, I counted in the forward direction and also counted in the backward direction. When I counted in the forward direction, the substituent fell at what carbon? Carbon 1. But when I counted in the backward direction, the substituent fell at what number? Carbon 5. So which should we go for? What did I say? The substituent should have a very low number as possible. So definitely, I'm not to count backward, I'm to count what? Forward. But it doesn't work that way always. Do you understand? It varies. That's why I said, make sure you number forward and also number backward to make sure that you get the correct numbering for that organic compound. So I've cancelled this part. So we'll follow the carbon to which the substituent fell under, which is carbon 1 in this case. So definitely, but before we do that, how many carbons are we having here? We are having 5 carbons. So a 5 carbon organic compound should be called pent. Do you understand? Pent. And this compound, is it an alkane? Yes. So definitely should be called pentane. And for the substituent, it fell under carbon 1. So definitely this compound becomes 1. And now this is bromine, but in naming organic compound, bromine's name will change to bromo. Remember, bromine is an halogen alongside chlorine, fluorine, iodine, astatine. Astatine is radioactive. Do you understand? So for bromine changes to bromo, chlorine changes to chloro, fluorine will change to fluoro, iodine as well will change to iodo. Do you understand? So this is bromine changes to bromo. So it's going to be 1 bromo pentane. Do you understand? But please note, between numbers and letters, we use dash to separate them. So this is the name of this compound. I believe it's actually very easy. It's actually very easy. It's not difficult at all. All right, so I'll be giving you one practice question. Okay, I want to just change the format to which this question was asked and give you yours. Let me see if you'll be able to get it. I believe you can actually solve it. It's actually very easy. So I've removed the bromine here and changed here to H as well. I replaced it with hydrogen. And let's say the bromine was here, for instance, Br. Okay, let's see if you can be able to name this compound. It's actually very easy. So make sure you provide the answer. So this is the first practice question for this video. So you write question 1 and put the answer. So we'll know the compound you are naming. Okay, so I can actually scrutinize your work and everything. But I believe you'll be able to get it. It's actually very easy. Please follow the steps. You'll be able to get it. I believe you. So that's for that. So let's get into this other practice question. Now, first of all, what was the step? Identify the longest continuous carbon chain. So let's identify, which is this as well. So the next step here is to number the longest continuous carbon chain. Please, what did I say? Number forward and also number backward. So let's say number 1, number 2, number 3, number 4, number 1, number 2, number 3, and number 4. Now, which of the numbering are we to follow? That's the question we ask ourselves. Which of the numbering are we to follow to name this compound? It's actually very easy. You have to watch closely as I explain this. Now, when you look at a particular organic compound and you saw many substituents, because now I'm seeing bromine as a substituent, I can see chlorine as a substituent up, and I also can see chlorine here down. So when you are seeing many substituents, you have to now make sure that you follow alphabetically. Do you understand? So it is the alphabetical order that will determine the direction to which we'll count from. Do you get? So the point I'm trying to make here is this. If you observe B, bromine, and Cl, B and C, or bromine, bromo now, and chloro, which one comes first when you are counting alphabetically? Letter B comes before letter C. Do you understand? So with this alone, this will make me count like this. Do you understand? I can't count like this, because if I count like this, chlorine here we have number 3, and it doesn't work. Please note, when you're having different alphabets, different substituent, follow alphabetical order. Do you understand? Please note, this is actually very important. So you can see that we have to count in this direction, so follow closely. Now let me quickly explain to you a trick on how to know specifically or to confirm what we just said, that we are to count in this direction. Please watch closely. Now let's bring our mind to the forward direction. Let's say, for instance, no numbering were here. Let's say this numbering, let's just remove it so that it will not confuse us. So please watch closely. Now if you observe, as we're going forward, at carbon 2 we had bromine, so write that 2 there and write plus. At carbon 2 as well we had chlorine, so write that 2 again. At carbon 3 we had another chlorine group, so write 3, you plus it with 3. So let's add them together. 2 plus 2 was that 4. 4 plus 3 was that 7. So when we counted upward, we had number 7. Please note, remember I said that your numbering should basically have a very low number as possible. So let's use the downward direction. Okay, let's work with the downward direction. So backward direction rather. So here becomes 1, here becomes 2, here becomes 3, and also here becomes 4. So here, let me remove this one for instance, but this is the correct way to count, okay, from my explanation. But let's finish first. So now if you observe, at carbon 2 we had chlorine, okay, so I'll put that. At carbon 3 we had another chlorine, and also at carbon 3 again we had bromine. Do you understand? So 2 plus 3, what is that? 5. 5 plus 3, what is that? 8. Do you understand? Which one gave us the lower number? The up direction. Definitely this is the best way to count. Do you understand? If you're like still like finding the what should I do, what should I do, please do this I just said. Take your time, you get it. Practice makes perfect. So definitely we've confirmed that this is the best direction to count. We can't work with this one. So here we'll follow our normal direction. 1, 2, 3, and 4. So this is out already. Do you understand? So let's work with the upward direction. So in summary, first of all, you check the alphabet and know where to start counting from. And after you've done that, confirm using this number style I've just explained. It's actually very easy. So the next step we do is to now, since we are counting from here, so at carbon now, first of all, we've numbered and we've seen that we have 4 carbons. So definitely these guys should be called butyl, but since it has single bonds, is an alkane, definitely should be called butane. And now at carbon 2 I had a bromine group, so 2 bromo. Remember, between numbers and letter hyphen. And also at carbon 2 as well I had chlorine, so here becomes 2 chloro as well. At carbon 3 I had another chlorine, so here becomes 3 chloro. Do you understand? But we can't just put if I have to name it, let's say 2 bromo, 2 chloro, 3 chloro. That's stress. Try to bring both of them together since they have the same group. So it's going to be something like this. These two guys, I want to measure them. It's going to be 2, 3. How many chloro are you seeing in this group? 2. So you use the prefix di. So it's going to be 2, 3 di chloro. Do you understand? Now, please note. Are you not seeing numbers? What should separate numbers and number? Comma. Do you understand? Comma should separate numbers. And numbers and later, what did I say? Hyphen. Do you understand? Or dash. So it's going to be 2,3 dichloro. That's, I've merged these two groups. So definitely, let's form the full name of this compound. So it's going to be something like, and now alphabetically, B and C. You are not using this to count alphabetical. The prefix does not account for the alphabetical order. It is the group's name. Bromine comes for chloro. Do you understand? Bromo comes for chloro. So it's going to be 2-bromo. Do you understand? Okay. 2,3-dichlorobutane. Do you understand? It's actually very easy. So the name of this compound becomes 2-bromo 2,3-dichlorobutane. That's the name of this compound. It's actually very, very easy. So I want to give you one practice question so you solve and provide the answer in the comment section. And let's say, let me restructure it. Let's say I put Cl here, I put Br here, and also I put I here. This is iodine. Remember, iodine will change to something like iodo. So I believe you can do it. Take your time. You'll be able to solve this question. Okay? It's actually very easy. So let's get over to the next practice examples. Okay, guys, moving further, let's name this particular question together before we go over to this and also go over to this. Now, it's actually very easy. If you observe now, you can see that the format to which the question can be asked is now becoming different, but it's actually the same thing to follow. It's actually the same steps to follow. It's actually easy. Please watch closely. Now, I believe you can see the way this compound works. Before, you'll be seeing something like carbon bonding to carbon, bonding to carbon, bonding to carbon, and hydrogen. You'll now be seeing different groups. Do you understand? But if you observe closely now, this particular compound, they actually condensed it. It's still the same step to follow. They condensed it. It was not in the structural form anymore. They can condense it. So when you see a question like that, what will you do? It's easy. Let's work together. So the step still remains the same by identifying the longest continuous carbon chain. Now you have to look at the connection of your carbon to know the one that was longest. Now, if you observe, if I count like this, look at this connection. I can see 3 carbons, but is that the longest connection? No, that's not. If I count like this, I can see 4 carbon like this. 1, 2, 3, 4. That's a very long connection. So that could be a long continuous carbon chain. Do you understand my point? And do you think I can count like this? I can connect it like this, bring it this way? No, it can't work like that. You have to identify the longest continuous carbon chain so it don't have like a branch. Do you understand my point? So the point I'm trying to make here is this could be a long continuous carbon chain. This one I'm doing now is a long continuous carbon chain. Do you understand my point? I cannot come here and now branch another this cannot work. Do you understand my point? So we have to basically identify the longest continuous carbon chain whereby one of the group remaining will not become the branch, will not become the substituent. Do you get the point? So now we've identified, and remember what was the step? Number the longest continuous carbon chain. Number forward and also number backward. So here it becomes my carbon 1, my carbon 2, carbon 3, and also carbon 4. Let's go like this: carbon 1, carbon 2, carbon 3, and also lastly carbon 4 as well. Now we have to make this the substituent, so our substituent should have a very low number as possible. So the point I'm trying to make here is this. And how is this compound an alkane? Yes, an alkane because it has single bonds connected. Do you understand? Connecting the carbons and also hydrogen. So it is an alkane rather. It is an alkane. So definitely, if I counted like this, a substituent will fall under carbon 2. But if we count like this, the substituent will fall under carbon 3. So will this work? No, we can't count like this. We have to make sure we count like this so that the substituent will fall under a low number. So that's for that. So you can see that the substituent fell under carbon 2. And what is this substituent called? This substituent is called methyl. Do you understand? Now, what's the chemical formula for methane? Methane chemical formula is CH4. Do you understand? CH4. This is methane. And methane, if you don't know it, please know it now. Methane chemical formula is CH4. This is methane. And methane is an alkane. And also we have a very special group, they call them alkyls. What are alkyl groups? Alkyl groups are derivatives of alkane that loses one hydrogen atom. Do you understand? So methane already is CH4. So let's work to get an alkyl group. This is methane, CH4, which is an alkane. Removing one hydrogen from this, what do you think you get? CH3. And we already call this guy methane. So what will you call this guy? Using the alkyl format, you call it methyl. Do you understand my point? So this guy is called methyl. Do you get? Please, as you've seen now, please don't forget, anytime you see CH3, you don't have to do what I've done. Just know that it is methyl. So definitely, and now, since we already say that it has 4 carbon, definitely should be called but. And since an alkane should be called butane, so definitely we had a group or a substituent at carbon 2, so it's become 2-methyl butane. Do you get? That's the name of this compound. It's actually very, very easy. So let's get into this other practice example. Now, moving further, let's get into this other practice example. Now, if you check carefully, you can see that we don't have bonds here, no bonds, and all of them are just condensed together. It's easy. Please watch closely, because in the exam they might bring it this way. So what will you do as a student? So please watch closely if you want to solve this particular question and name it together. Let's name it together. So the first thing we do, we have to try to draw. Now, it is in this compound is expressed in its condensed form. They condensed it. So let's try to bring out the structure out of this compound. So the first thing, we had carbon. Now remember, in organic chemistry, carbon is what? Tetravalent, meaning that it only allows 4 bonds to surround itself. So this is the first carbon we are having here. Okay, and now what did I say carbon allow? How many bonds surrounds carbon? How many bonds does carbon allow to surround itself? 4. So definitely we have something like this. Let's start like this. Okay, so there will be space for us to write. So I said that the first carbon should allow how many bonds? 4. So we already having what? Please watch. 3 hydrogen attached to this carbon. So the hydrogen should come up 1, 2, and 3. Do you understand? Whereby the last bond should connect with this carbon. Do you get? And how many hydrogens connecting this carbon? 2. So it's going to come up and down. So the hydrogen 1 and also the hydrogen is complete. So moving further, this bond will not connect with the last carbon, because we have 3 carbons initially, 1, 2, and 3. So we already written just 1 and 2. So this carbon should be here. So it's going to be here. Please note. And now we have 2 hydrogen atoms. Okay, definitely you already know that carbon allows how many bonds to surround itself? 4. So this is the 4 bond. 1, 2, 3, 4. So definitely let's put this chlorine group here. Do you understand? And pull one of them. You can try to do anything, but just follow the format, please. H should be here, one of the hydrogen, and the last hydrogen should be here as well. Do you understand? We form the structure of this compound. Do you get? I believe you are following. It's actually very easy. So the next thing we have to do here is to now name it. Remember I said that you must count. Do you understand? Identify the longest continuous carbon chain, which is this, and also count forward and backward. So here should be number 1, number 2, number 3, number 1, number 2, number 3. So then if you count from this direction, chlorine, which is the substituent, will fall on which carbon? Carbon 1. If you count from this direction, chlorine will fall on carbon 3, and we don't want that because it's a large number. We say the substituent should have a very low number as possible. So this guy is going to be, now how many carbons are here? 3. So it should be called prop, but since an alkane should be called propane, and definitely we'll call it 1-chloro, because that's chlorine group, propane. Do you get? It's actually very, very easy. So I want to give your own practice question, so you solve and provide the answer in the comment section. And here I will change. Now this is your own practice question, whereby here will be CH. You know it was CH3 before, so I was saying to CH2, and here will be Cl as well. So we have 2 chloro groups here. I believe you can name this compound. Please follow step by step. You can actually do it. So lastly, let's walk towards this compound. We have to basically bring the structure out of this compound that was condensed. The first thing we have to do is to basically write this first carbon. So carbon connected to 3 hydrogens, okay? We'll do the connection. The first hydrogen, the other hydrogen, and also the last hydrogen. And then it's connected to this carbon. Do you understand? And this carbon is connected to 2 bromine atoms. So here it becomes B arrow, and also here it becomes B arrow. And lastly, connected to this last carbon, which is connected to 3 other hydrogen atoms. I believe you are following. It's actually very easy. And what was the step I told? Identify the longest continuous carbon chain and also number it in forward and backward direction. 1, 2, 3. 1, 2, 3. Now, if you observe, insofar the direction we number, our substance will still fall under carbon 2. When we numbered like this, the bromine and also bromine fell on carbon 2. When we numbered like this, the bromine fell on carbon 2 as well. So we can actually just pick one of them. Both of them are correct. So first of all, it is a 3 carbon compound. So then it should be called prop. Do you understand? Since it's an alkane, it should be called propane. And now the group here is what? We have bromine at carbon 2. So it's going to be 2 because we have 2 bromine groups at carbon 2. Do you understand? That's why it should be called 2,2. How many of them die? Bromopropane. Do you understand? So for instance, this bromine was here, for instance. Do you understand what you know? Like, if it was here, for instance, now what will you do? You call the number to which that bromine was found. But because it was in carbon 2 and we had 2 bromine, that's why it's 2,2-dibromopropane. That's the name of this compound. So I'll give you one practice question so you solve and provide the answer in the comment section. It is very, very easy. And this is yours. So I want to elongate this by putting here as CH bracket Cl close bracket, and here becomes CH3. You can do it. Solve this question. You can say I've elongated it. So just follow the steps I've given. You'll be able to name this compound. So I believe now naming alkanes, the IUPAC nomenclature of alkane, will not be a problem for you if you follow all the steps I gave in this video lesson. Okay. Now, if you find this video lesson helpful, make sure you share these lessons with your friends, at least 10 of your friends, or maybe study group chat. Send the link to your friends so that they can be watching it, and before the JAMB exam commences, you'll be very grounded in this aspect. Not just the JAMB, the WAEC exam, and other chemistry related exam. And also, if you are even in a university in your first year, all of these lessons will help you improve greatly. So if you find this video lesson, make sure you subscribe to this channel. Thanks for watching. To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.